Hi everyone, welcome to my presentation today here at NahamCon 2022. My name is Shabam Shah, and today I'll be presenting about finding 0 days in enterprise software. I'm the co-founder and CTO of AssetNote, an attack surface management platform. We often find vulnerabilities in enterprise software for our customers, as well as generally for the wider security of software in vendors. The first piece of software I'll be talking about today is HCL Digital Experience. It's also known as IBM Websphere Portal. It's a piece of software that's written in Java and runs on IBM Websphere server. It's used by enterprises and is a very flexible content management system. There's around 4,500 instances on the internet, and it's self-hosted, as I said earlier, on IBM Websphere server. It's got pretty widespread usage amongst the Fortune 500 and other companies running bug bounties. So how do you get a copy of it? So it's not that difficult actually. Whenever you're looking for enterprise software, one of the key things I can tell you to do is to look for it on public services like Docker Hub. Docker Hub often has copies of enterprise software that either someone has pushed as they were doing some sort of development, or even officially has been pushed by the company. In this scenario, IBM have pushed a version of Websphere Portal at some stage that we can download locally and start running on our instance. This isn't always the case. These days, a lot of enterprise software is locked up behind sales processes, and sometimes it can be quite tricky to get access to enterprise software. Thankfully for Websphere, it wasn't too difficult, and we're able to get a local instance running quite quickly. The next thing is decompiling the jar files. Now, this isn't the same for every enterprise software, but we realized that Websphere Portal is written in Java, and ultimately it's deployed in a similar way to how you'd deploy web applications through something like Tomcat, except on Websphere application server. So what we do is we ultimately find the location of all the jar files, and we compress them into a tar file. We get that onto our local system, and then we use our favorite decompiler to decompile all the jar files. In this scenario, I use Procyon decompiler, but ultimately you can use anything you want, like JD CLI or JD GUI. This will end up with a bunch of source code that you can start auditing. This is an easy way to get to a point where you can start auditing source code immediately. But before you start auditing the source code, what I'd recommend is mapping out the attack surface. So to find the attack surface, we can run this command, which will return all of the different mappings for this application. Obviously, this is specific to this application because it's using Websphere application server, and it's mapped in this way. Each enterprise application is going to have a different way of doing routing and mapping, and you need to determine that before you can find what to run to get the exact details you're looking for. In this scenario, we can see that there's quite a few mappings available, and there's a lot of attack surface for us to go through. But as we started to progress down this list, what we ended up finding was this really interesting file called proxy-config.xml. And it was really surprising, because when we found this file, we saw that there are a number of paths that were defined, and there were also 3 URLs that were whitelisted: www.ibm.com, www-03.ibm.com, and redbooks.ibm.com. Immediately, this sparked our curiosity. We thought to ourselves, okay, this seems like there's some sort of outbound proxy here, and it seems like these 3 URLs are whitelisted. Some of the questions that we thought about at the time were, is this, 1, protected by authentication, and 2, is there any sort of support for something like redirects? Because even if there's a policy URL here, if it supports redirects, we might be able to bypass these policies. One of the hard things about mapping things when it comes from looking at the mappings that we found earlier back to endpoints on the system, on the application, is that is the difficult part sometimes. Knowing that there's a mapping available isn't enough. You need to be able to know where you can hit the application to reach that mapping and that piece of code. So this one was pretty easy. It was deployed under /WPS. So we found that there was /WPS/proxy, myproxy, common proxy, and so on. But the proxy config file says that we can only access ibm.com and redbooks.ibm.com. How are we going to turn this into a full read SSRF? Well, this is where the magic happens. we realized that redbooks.ibm.com runs a software called Lotus Domino to deliver content to users. If we achieved a URL redirect on this subdomain, we'll be able to achieve SSRF on arbitrary hosts. And after researching this software, Lotus Domino, we realized that there was some pretty old documentation around the sign-up process. This sign-up process allowed you to redirect people to arbitrary locations after signing out. So looking at this documentation, we can see that there's this simple command that there's a simple thing you can slap onto a URL, which lets you redirect to arbitrary locations. In this example, you can see $logout and redirect to equals http://www.sales.com, for example. So it's actually quite straightforward to understand that there is this redirect gadget in Lotus Domino, and we can combine all of these elements together to achieve full read SSRF. So you can see here that we can reach redbooks.ibm.com, and we can add the query parameter logout and the other query parameter redirect to with our host, and we can see the response from this web server. It's redirecting to the location we're looking for. So ultimately, we now have a redirect gadget on one of the whitelisted hosts that this proxy config has in its policies. We can pull all of this together and ultimately achieve full read SSRF. So if we put it all together, this is what our final payload looks like: /wps/proxy, redbooks.ibm.com, and then we've got the logout and redirect to parameters at the end. And ultimately, we're now proxying to arbitrary locations on behalf of the web server using this redirect gadget. So this one's pretty exciting because it's not just a straight SSRF, we're actually using a redirect gadget to finally get to our location. And this is why often open redirects are more valuable than most people think. In scenarios like server-side request forgery, an open redirect could be the difference between a successful exploitation of the SSRF versus unsuccessful exploitation. The next thing we did was variant hunting. Now, this is a common technique that vulnerability researchers do when they detect a vulnerability. They look for all the different variants in the code base that may also have that vulnerability. So we ran the command, this find command, to look at all the other proxy config files on the system. We found a number of hits, and we went through all of these systematically. You can see here that I've highlighted these two hits in particular. That's because these hits actually were the most impactful in my opinion. If you take a look at the policy, it allows you to proxy to any URL using all of these different methods. This is even worse than the initial SSRF we found in Websphere that we just went through with Lotus Domino. So it's really like a super SSRF. You can hit this endpoint, and ultimately you can send any request method, and you can have any body, you can have any headers, or you can have these headers as well. And ultimately you can proxy to anywhere on the internal network using this exploit. So variant hunting is very powerful and something that I highly recommend you do when you are auditing enterprise web applications. Once you find a single vulnerability, try and find all the different patterns and locations in the code base that mimic that vulnerability or that behavior, because you'll often find that a mistake made once in code is made elsewhere as well, or in config. So you can see here that this SSRF works really well. We don't even need a redirect gadget. We can hit any endpoint, any URL, and we can also have any method that we want and any body as well. So it's basically a super SSRF in Websphere portal. The next thing is I did look for more variants, and I found that there were some other locations in the code that you could reach this proxy functionality. So these are some examples of how else you could reach this proxy functionality. So really what it meant that, WAF rules weren't really that effective because there's so many ways to ultimately reach the proxying functionality. It was also possible to use the redirect gadget in these two scenarios to achieve full read SSRF as well. Here's just an example of it running locally. And another variant that we found was inside the quicker document picker, and it had an internal proxy as well. And looking at the internal proxy and also the common proxy, is very straightforward. You could just hit these two endpoints and also proxy to any URL, any location. One with the redirect gadget and one without the redirect gadget. This is again a full read SSRF pre-auth, but it's limited to GET requests. Once we found the SSRF, we wanted to see if we could chain the vulnerability to gain further impact. And one of the things we realized with IBM Websphere Portal is that it has this software called Knowledge Center that's running on port 9043. We thought that through our SSRF, we can access this port and hence this functionality. And inside the web.xml file, we saw this interesting route called JSONP callback filter, which was at, that's the filter. It was called API/webfeed, which we thought could have further vulnerabilities inside. So naturally, we downloaded the Knowledge Center WAR file and we decompiled it and looked at it in our source code. Looked at the source code, and we found that it's downloading a arbitrary URL and then it's performing XML parsing on the contents of that URL. And we thought, okay, this looks amazing. This looks like we can probably get XXE through this gadget. But what we ultimately found is we tried it on a bug bounty target and it just returned forbidden and it didn't work. Even though we could hit the Knowledge Center port and the URL and everything, it just returned forbidden. So it was a fail. But we had to work out why it was a failure, because everything in the code made it seem as if it should work. And we realized that once we downloaded an even newer version of this software, that this was basically patched. We downloaded a different Docker image that seemed to be a newer version of Websphere, and it was effectively patched because you can see here it has at deprecated and essentially returns a forbidden exception instead of actually doing anything. The big lesson we learned here was make sure you have the latest copy of code before testing your vulnerabilities. But this is often something that you don't have access to. In this scenario, we only had sparse access to Websphere and the copies on Docker Hub and things like that. So I guess if you can, always make sure you have the latest copy if you are looking at targets in the wild. But in many scenarios, I understand that it's not going to be possible. We had another attempt at XXE, so we tried crafting a payload like this and base64ing it, and then we tried hitting this resource proxy portlet, which takes in XML as a base64, and we thought maybe we can get XXE this way. And this was obviously found by auditing the source code, and what we found was ultimately it was well protected against XXE. None of the DCDs were being resolved, and we weren't able to successfully achieve XXE. Now, one of the things is I'm talking about the failures here just so that you understand that source code auditing isn't always glamorous, and you're not always going to find amazing vulnerabilities. There's going to be a lot of failures along the way. There's going to be a lot of time spent on testing vulnerabilities, even when they might not account or they might not amount to real impact. We can see here that this failure at XXE, we can see that it's just not resolving any of the DTDs, and digging further into the source code, we can see that they've explicitly disabled any of the DTD handling or the resolvers for external entities. So ultimately, it was something that they had already patched, and it wasn't vulnerable to XXE. But yeah, talking about failures is extremely valuable. This sort of stuff happens all the time when you're source code auditing, so don't feel discouraged. Just keep on going and find more vulnerabilities. Spend more time on your target. You will find something eventually. One of the other vulnerabilities that we found in Websphere Portal was post-auth RCE via directory traversal. So there's this functionality to upload script applications, and it allows you to upload zip files that can contain HTML, CSS, and JavaScript. What's really interesting about this is that even though it's post-authentication, once someone does get authentication, it's likely that they can get command execution through this technique. So you can find it at this location that I've got in this slide if you're looking for it inside Websphere. And essentially you click this actions and import, and you can import a zip file. What we found was we can simply upload a zip file which has directory traversal inside it, and it will let us upload files to the local system at any location. So we can use this software called EvilArc, which will construct zip files with directory traversal, and we can create a file which has the following contents here. This will lead to RCE on reboot, which, you know, isn't too impactful, but if you are looking at this as an attack chain, this could be useful in the attack chain. You might be wondering why this technique works, like why can you put this file in this location and why will it lead to command execution? So essentially there's this amazing full disclosure exploit details where they talk about this technique where for whatever reason, if you can write this file to etc sysconfig network scripts and you do a reboot, you can ultimately execute arbitrary commands based on the name attribute. So anything after the first blank space in the name attribute is executed as root, or as whatever users are executing this. So this is an interesting RCE vector, something to remember, that if you do find a way to upload arbitrary files to the system, but you can't really get command execution, this is one of the possible techniques to get command execution by arbitrary file upload. Like for example, let's say you can't upload a shell for whatever reason, and nothing's really writable except some directories. If you can write to the etc sysconfig network scripts directory, you can likely get a shell anyways, if on reboot at least. Here are some references around Websphere and some of the things that I was looking at when I was auditing Websphere. I found all of these very useful. If you do look at this software, these might be useful to you as well. And lastly, here's the exploit write-up for Websphere. You can find a lot more details about this, a lot more details about the exact source code and things like that in this exploit write-up and the journey that we had to go through in order to find these vulnerabilities. The next software that we're going to look into is Solarwinds Web Help Desk. And we're going to see how we can hack Solarwinds Web Help Desk, which is another enterprise software that's used by a lot of large companies. So what is Solarwinds Web Help Desk? Well, it's essentially a central ticketing management system for your enterprise. It connects with Solarwinds Orion. It's used by medium to large enterprises, schools, government. There's around 2,000 instances of it on the internet. One of the things I want to quickly talk about is removing the stigma from huge code bases. So Solarwinds have this help desk product that is used by large enterprises, and the code base is absolutely huge. There's Spring, web objects, traditional servlets, all sorts of different things going on. And initially when you look at this, it can be really daunting to take a look at because of the scope. However, with some intelligent analysis of sources and sinks, it starts to get easier. My number one advice when it comes to auditing complex software is trying to map out as much of the attack surface as possible in forms of sources and sinks, and then do your auditing after you understand this. One of the first things we found when looking through the source code was this concept of hard-coded credentials. We saw that there was some JavaScript that had these hard-coded credentials in there, and immediately we started searching the entire code base for these hard-coded credentials. We found that there's actually production hard-coded credentials as well, and you can see them being defined as constants in the source code here. You can see that there's a login and a password that's defined here. Well, the first thing we thought about was, what does this let us access? These credentials seem to be a big part of the Spring web app embedded into the software, and there seems to be this really interesting controller which these credentials let us access over here. Surprisingly, Solarwinds were exposing endpoints that let you run arbitrary Hibernate queries. And Hibernate talks directly to the database based off models explicitly defined in Java. So what we found was these credentials let us access a Spring controller which let us execute arbitrary Hibernate queries. So this is what the Spring controller looked like. You can see that the endpoint was /raw_HQL, and it took in an arbitrary string that it would execute as a result. So getString HQL result would then create a query using that string, and it would get the results. Once we put it all together, you can see that the post request actually needed a few things for it to work, and we found this through trial and error. But essentially, it needed an SSRF token. It needed the basic auth credentials that we found earlier. It needed the CSRF token again in the cookie, and very important, it needed the content type being text plain. And lastly, in the post request, the full Hibernate query. This took a really long time to figure out all of these different elements working backwards. But one of the things that I was actually stuck on was the content type, and it took me forever to realize that text/plain was what was needed to exploit this issue. But ultimately it responded with an email address and a password hash, which is crazy. There was an endpoint that let you execute arbitrary HQL queries inside SolarWinds web help desk. And this was the vulnerability. What's not shown in this presentation, and something that I've kind of really glossed over, is the amount of time that was spent mapping out sources and sinks, understanding the authentication flow for some of the Spring routes and how hard-coded credentials enabled this vulnerability, numerous failed attempts at exploiting certain vulnerability classes in other areas of the code, the vast amount of code in this code base causing auditing fatigue, and also shouting F yeah after discovering the pre-auth critical bug. So these are all things that during the process of source code auditing you will often come across, and don't be discouraged if it takes you a long time to find these critical pre-auth vulnerabilities, but this is just an example of finding a vulnerability in a piece of software that's used by a lot of enterprises. The impact of this was that an unauthenticated user could run arbitrary SQL against SolarWinds Web Help Desk's internal database, and it would allow attackers to obtain usernames and password hashes from the database. It also allowed attackers to insert arbitrary data into the database. So an alternative vector is just replacing the password hash with one you've generated yourself or adding a new user. But it is limited to Hibernate SQL queries, and these Hibernate SQL queries will only work if there are models defined in Java. For the most part, almost every table had a model defined in Java for Hibernate, so you could access almost any table and run almost any query you wanted to. The exploit write-up for this issue can be found here. You can learn a little bit more about the mitigations that were in place that prevented mass exploitation, as well as some of the things that we worked out when diving deeper into the issue. As much as this presentation doesn't go into the really deep analysis of the source code, you will find that this exploit write-up does, and it should be a really valuable resource when you're trying to understand how these vulnerabilities worked or how we were able to discover these vulnerabilities in the first place. Another favorite piece of software that I hacked last year was called Sitecore Experience Platform. And this was one of my favorite vulnerabilities that I found in the last year, just because of, one, how widespread Sitecore is used in enterprises, and also how simple the vulnerability ended up being when it comes to exploitation. And the impact, it does lead to command execution, so it was one of my most impactful bugs that I found as well. What is Sitecore Experience Platform? Well, it's essentially a CMS that's used by large enterprises, government, banks, Fortune 500 companies. You can build a lot of digital experiences through Sitecore's Experience Platform, and there's around 10,000 instances or so of this software running on the internet exposed externally. It's a handful of bug bounty programs that were affected by discovering bugs in this software, and ultimately we were able to make a lot of money through bug bounties through this software. But not only that, a lot of our customers at AssetNote also ran this software, which was the most important thing for us in securing them. So a note on giving up, and this is something that you'll often feel like doing when you're auditing large code bases, is throughout your source code auditing journey, you'll want to give up all the time. In fact, when I was auditing Sitecore's Experience Platform, I almost gave up like 5 times. It was so tempting to walk away and not spend any more time auditing this software. Ultimately, not auditing the software costs nothing, and it's something that's really easy to do, just walking away and moving on to something else. But you have to be really motivated to find these software vulnerabilities through source code auditing. And when the code base is very large and complex, this can be pretty difficult. But my best advice is to take a lot of breaks. So every time you feel fatigued, take another break. Come back to the source code when you're feeling better. And this strategy has worked really well for me. What I will find is, I'll be auditing a piece of software and it might take me a week, 2 weeks before I find critical vulnerabilities. And honestly, it's really tempting to just want to give up. And the key is persistence. The key is confidence that you're going to find something and just keeping at it and keep going without giving up. So this is my note on giving up, and when it comes to source code auditing, it's particularly important. Things will get better over time. You will understand the code base better over time, so just don't give up, keep on moving forward. The first step in auditing Sitecore was obtaining its source code. Now, I obtained the source code by looking at GitHub repos, where people had posted the Sitecore web root to a GitHub repo. And I was able to find one that was relatively recent and looked like it was a really popular version of Sitecore, so I downloaded it all to my local system and I decompiled all the DLL files. I then opened up the Sitecore source code, the decompiled DLLs, as well as the Sitecore deployment folder side by side in Sublime Text. This was pivotal to understand the attack surface by looking at the C# source code and also looking at the web root and understanding what was exposed. Again, we have to map out the attack surface like we do with any enterprise software. And, Sitecore is complex. It has a lot of attack surface. And a lot of this attack surface is defined in the config files located in the app_config folder. But Sitecore also has a lot of ASPX and ASHX files in the web root as well. And inside the web.config file, we find the following line, which essentially says that this virtual folder is being mapped in the web.config file, and anything within this virtual folder can be executed. So what we can see here on the left is just the basic outline of the shell folder and what was included inside that folder. And we can see that, there's quite a few different ASPX files and folders and things like that. But really, the journey in mapping out the attack surface is not over yet. We still don't know what's pre-authentication and what's post-authentication. This becomes a little bit clearer as we iterate through some of these files and read the source code to see whether or not there are authentication requirements, but we still need to do that in this journey. Discovering the vulnerable endpoint was pretty interesting because inside one of these folders I found a file which was called report.ashx and it had the following contents. Basically just referred to a C# file called report.ashx.cs. And since we've loaded up all of our source code into our IDE, we can check that source code simultaneously while looking at this ASHX file. So we found that the source code was located in this directory called report.cs, and we opened it up. This is what report.cs looked like. Ultimately, it was processing the request, and it was it was ending up at the sink ReportDataSerializer.deserialize query, where it took our input stream as input. When we look at ReportDataSerializer.cs, we can find that our sink here was ultimately netDataContractSerializer.read object. Now, for people that aren't familiar with source code auditing or specific quirks of languages, this is incredibly dangerous behavior. In .NET, there's always been the issue of insecure deserialization, or at least since the last 4 or 5 years, it's been more widely known and publicized, where if there's arbitrary input from the user ending up at one of these dangerous sinks, for example, netDataContractSerializer.read object, you can achieve command execution. There are so many more sinks just like this, and there are so many different quirks inside languages that let you do dangerous functionality or dangerous things. Thankfully, when I was auditing the source code, my understanding was if something is being deserialized, we should check whether or not it is happening in a safe way or not. And anything that looked like it was deserializing, I would investigate further to see whether or not it could lead to a dangerous outcome. In this scenario, we can see that the sink netDataContractSerializer.read object takes in the input that we provide, and ultimately that data gets deserialized. So to craft the payload, we used Writeup, which thankfully has a gadget available for netDataContractSerializer, and we can just do a simple gadget like this and generate the base 64 for that gadget. Our final payload looks something like this, which had query, source, parameters, and the parameter name, and the serialized XML object. This payload was crafted by looking at the source code and understanding how do we get to that sink? What do we need to do? What do we need to include to get to that sink? And really what we needed to do was craft this specific XML file, which would lead to the sink inside the parameters tag where the serialized XML object is. Our final RCE payload looks something like this. So you just send a post request to report.ashx with the XML payload and the serialized XML inside the parameter tag. The exploit write-up for this can be found here. It has a lot more detail about the vulnerability, how we found it, some of the things that we had to do to come up with the exploit payload, and I hope that it's more insightful for you to read this write-up than just this presentation, because it does have a lot more extra information as well. Lastly, I want to talk about VMware Workspace One UEM, which is also known as AirWatch. So Workspace One UEM is used for mobile device management, mobility management by enterprises. It's for the administration of mobile devices such as smartphones, tablets, laptops, and MDM is usually implemented with the use of a third-party product like Workspace One UEM. VMware acquired AirWatch and then renamed AirWatch into Workspace One UEM. Almost every large enterprise has some sort of MDM solution, and this software is actually a really popular solution that a lot of enterprises use. As usual, we've got to map out the attack surface. So one of the things that's pretty funny is installing Workspace One UEM was almost harder than discovering the vulnerability, which is many times the case when looking at enterprise software. These folders inside the websites directory were deployed under different virtual paths. So you can see on the right hand side there's all these different websites like devices gateway, catalog, device management. They all had different virtual paths when configured through IIS. And there was some presence of some ASHX files, which is what we focused on initially when looking at the attack surface. Some of these ASHX files weren't protected by authentication. One of the ones that we focused on particularly was something called blobhandler.ashx. This file existed in multiple virtual paths, however the ones that we found that were vulnerable were only on /airwatch and /catalog. The endpoint was accessible pre-authentication, and there was no authentication logic that was found within the code or the web.config files. And as you can see here, there was this function that we found within blobhandler.ashx called render proxy response. It took in an encrypted URL, and then it would proxy that encrypted URL directly. This was incredibly interesting to us. The first question we had was, how can we generate our own encrypted URLs? So the logic was essentially, as long as we provided an encrypted URL, a HTTP request would be made to this encrypted URL. You could control the method, you can control the body, the headers, and the full response would be proxied back to the user. This functionality was not in use by literally anything else in the code base, and it was a big question for why it was implemented in the first place. Essentially, it's a full read SSRF with full control over the request if we work out this encryption algorithm. The encryption function looks something like this. It would obtain a master key, and then it would return a function with that master key and encrypt using that function. When we looked at the function to get the master key, we realized that the logic was actually quite flawed, and it would return the default master key in most scenarios. So you can walk through this logic pretty easily. You can see that it uses the key version to determine whether or not it returns the default master key, but you can see that it returns the default master key in two scenarios. If the key version is empty or it equals KV0, or also if the master key from the database is null or the master key from the database is not valid. But yeah, ultimately this was the functionality that was being used to encrypt arbitrary strings, and also the functionality being used when you needed to encrypt a URL to provide to AirWatch or VMware Workspace One UEM. We realized that the default master key was just hard-coded in the codebase. So you can see that here's the key version, the passphrase, the salt data. And at this point, we were pretty confident that if we were able to use this master key to encrypt our own URLs, we would be able to get full read SSRF. So what we did was we hooked into the source code, we hooked into the DLL files, and we ultimately hooked into the encryption functions defined in the DLL files in order to make our own encryptor. We leveraged the already existing functions for encryption, and we were able to create a CLI application that was capable of encrypting arbitrary strings. This allowed us to specify arbitrary URLs to be encrypted, which could then be used for when requesting blobhandler.ashx. This successfully led to pre-auth SSRF. The final exploit looks something like this. We had a Python script that would do all of the work with the encryption, calling out to the binary that we created. It would take in a URL and the SSRF target, and then it would generate an SSRF payload. This is an example SSRF payload that will request example.com. The write-up for this can be found here. This has a lot more detail in the write-up, and it explains the whole encryption algorithm, how we hook in the POC and things like that. So I highly recommend you check out this write-up and see if you can recreate this yourself. That's all I have for today. Thank you very much for joining and watching this session. I hope that you learned a little bit about source code analysis. I know that ultimately I was just explaining vulnerabilities that we found through source code analysis, but I feel like I had a few really important lessons throughout this presentation. I hope that you can learn something from my journey in source code analysis, and I hope that I helped you in some way. Have a great day.